Now let us discuss about the secondary walls. We had seen how to create the primary wall. This wall is the feature by which we can create the primary wall. Now when we have to create the secondary walls, what all options we have by which we can create the secondary wall and continue our sheet metal work. Remember, we are using the first approach using sheet metal environment is by adding the walls. So what I'll be doing is to this primary wall, I'll be adding another wall. I'll be adding another wall, and like this I'll be keep on adding the walls to get the final result. Practically this particular thing, adding the wall, is not possible when you talk about the production thing of sheet metal entities. But for modeling, yes, we do have this particular approach available which we can follow and get our desired result in some easier manner. So let's have a look at the secondary walls now. If I'll talk about the secondary wall, so one of the secondary wall I have is wall on edge. I'll click on it. It is asking me select an input edge, means with which edge you want to add the wall. So just focus on this particular edge. If I'm selecting the upper edge, then you can see it is generating a wall on the upward side. I can go for reverse, so it will automatically go with the downward side. This is your direction after wall on edge. Then there are some functions available which would definitely help us in creating it in the proper manner. Now just observe over here. In the dialog box, if I'll check, so there is an option for height, how much height I want to maintain for the next wall, and what angle I want to maintain. You can see I can give the angle as per my own requirement. Remember, it is not asking me the bend radius. I had given in the sheet metal parameter 2 mm thickness, 4 mm bend radius, which is this one. Until unless defined, by default what we consider is the inside thickness, because whenever you apply the punches on sheet metal, it is being applied from the internal side only. So this particular radius is 4 mm. You can see with bend this particular thing is already with respect to a formula which we had defined earlier. So this is with bend 4 mm radius it is following, and it is giving us the result of bending or adding the wall basically. I'll keep it 30. Now to maintain the proper dimensions, we have this clearance mode available. Height is given, angle is given. I want the clearance mode to be maintained. By default the option is no clearance. Observe the condition of no clearance. What is happening whenever wherever my first wall is ending, that primary wall's end is coincided with the internal face of secondary wall. Have a look at this. They both are at the same level. The internal edge of secondary wall is coincided with the end of primary wall. If I'll change this to say monodirectional, observe the changes. Monodirectional is actually allowing me to give the dimension, say giving 1 mm, 2 mm, 3 mm, 4 mm. See what is happening. I am actually able to move inside or outside to generate the wall. If I want to adjust the length, then I can do using this monodirectional option. And if I'm keeping it as 0, which is a default case of no clearance. So if anywhere I want to uh, add some dimension, or I had given some wrong value, then by means of this particular clearance mode option I can actually maintain that distance. Or the third option we have is the bidirectional. In the bidirectional clearance mode, the created formula linked the wall position with sheet metal parameter bend value. What will happen? It will follow the bend value. I'll say okay. This is how it will follow the bend value. Your bend will start from the end of primary wall. After that it will create that bend and it will give you the result. So that definitely in this particular case, when the bend radius is 4 mm, this will give a difference of 4 mm this side. If this particular base is of 100 mm, now till this value, till this level it will be 104 mm, and till outside it will be 106 mm. So yes, whenever we create the sheet metal entities, we need to focus on these dimensions as well. Otherwise, what will happen, there would be either some extra dimensions available or there would be some less dimensions available if we will not focus on this particular clearance mode thing. So these are the clearance modes we have, and this is how the wall will be added. This particular is the case bidirectional. If I'll go for no clearance, this is how I'm going to get the no clearance mode. The result would be same, but the location, the dimension would be different. So as per your requirement, yes, you can do this. Then I had selected one edge, I am getting the result. Let's try with multiple edges. Using control, I had selected another edge. What I'm doing is I'm applying a wall and edge on both the edges at a time with the same parameters. I'll be able to get the result. So wall on edge applicable on a single edge, applicable on multiple edges as well. What I am going to get as a result is a secondary wall with a specific bend radius which I had already defined in the sheet metal parameters. I can maintain the angle, I can maintain the clearance as well. This was the type automatic. Even I can apply it on multiple edges as well. Okay, let's select this one as well using control. You can see I can apply it on 3 edges. Select it. Next one, 4 edges. Yes, I am able to apply it on all 4 edges, maintaining the proper dimensions, and I am able to get the result. Say okay. This is how the result will look like. Okay, let's change the mode to no clearance. Now see, when I'm going into no clearance mode, what will happen? It will automatically generate some reliefs over here. This is what reliefs are. This gap it is maintaining, because if you will not maintain this particular gap, what will happen? You will not be able to bend or fold this particular sheet in the proper manner, because this would be the case. If you will go for bending this, then definitely this would coincide or this would get deflected. If you'll go for bending this, then definitely this would get deflected. That's why this particular relief, this particular cutout is given over here, and the result has been shown to you. Because that particular case, if you are not giving any reliefs, that particular case practically is not possible. That's why software has automatically generated those reliefs over there. This is your wall on edge case. Then this height case, what you can give as a height value, for that also you have options available. See, just focus on this case: outer to outer, inner to outer, bend ending to outer, or the extreme outer case. Which particular value is given to you, select that and give that value as a height over here. You don't need to calculate anything. This is the advantage. If I'm talking about the extremities, so you can see these are the extremities, basically the offsets that you give. See, I'll just deselect other three edges so that it would give you a clarity. These are, this is the case. So you can see I had given the left offset. See what is happening. It has selected the complete edge, but if I want to apply on a specific length, then that also I can do. See, from the right hand side 14 mm distance, from the left hand side 13 mm or say 14 mm distance I am maintaining, or I am leaving this much distance, and then I am applying the bend. So complete sheet has not been bent, only this much is being bended. But again there is a case. Practically if I'll go for this case, that is not possible. Over here we will need the reliefs. Over here we will need the reliefs. So in that case what I'll be doing, I'll be going for sheet metal parameters, and here bend extremities we had given minimum with no relief. I'll change it again as per requirement. If square reliefs are given, I'll be giving the square reliefs. Round is given, I'll go for round. Linear, tangent, whatever type is given, I'll select that. Say square relief of the length 1, length 2, and say OK. See, the square reliefs has been generated of the dimension which I had defined on both the sides. This is the use of reliefs. Now these square reliefs are applicable in all the cases wherever the applicability of relief comes into picture. So this was your wall on edge automatic type. I'll just make these values as 0 again. When the value will be 0, there will be no case of reliefs, because no such tearing of surfaces or tearing of sheet will be happening in that case on a single edge. Okay, so this was your automatic type. If I'll talk about the sketch based type, click on it. It will ask you to select the profile. For profile I need to select the sketch which is not been created. So I'll be creating the sketch. For creating the sketch I'll need to select the plane. I'll go for this sketch, say on this face, and now I'll start working for sketch creation. So this particular edge I want to work with, because this is the edge from which the bending will start. Now here I'll get the control for the profile creation. What type of profile I want for the secondary wall. Definitely I need to make it a closed loop. So a closed loop profile I have created. This is the shape, this is the profile I want for secondary wall. I have created. I'll say exit to the sketcher, and you can see this is how the secondary wall will look like. So instead of getting a rectangular wall, if I want some other shape, then I need to switch from automatic to sketch based, and all other options are same. Angle I can define, clearance I can define, and I'll say OK. This is your one of the type for secondary wall creation. Name is wall on edge. I hope this particular thing is clear to you. Next, let us discuss the next type of secondary wall. Uh, this is again a secondary wall which would be created by means of edge only under adding walls category. The name of that wall is actually flange, and you can see there is an arrow. So there is a flange sub toolbar we have. Basically, four types of flange or swept walls are there as per specific shapes. I'll click on it. Flange, first type I'll select. Just have a look at the shape. As per the shape, you have to define the parameter. Here I'm selecting spine. So selecting this. Now the case is reversed. In case of wall on edge, when I was selecting the upper edge, the wall was created upward. Now I had selected the upper edge, the wall has been created downward. This is the major difference, one. The second thing we have basic type. Okay, length I can define. For the length, again all four options are available. Angle I can define as per my own requirement. I do have the option available for defining the radius, which was not available in case of wall on edge. If I want to trim the support, then I can trim the support as well. If I'm creating it inside, then I can trim the support as well. Invert material size, reverse direction, all these options are same. This is your flange wall. Double click on it. This is your basic. Another one is relimited type. Relimited is basically from where till where you want to create. Okay, in that case you will need to select the planes. As per that you will be able to get the desired result of relimitation. I want this particular wall to be limited. Say we'll be creating two planes. Okay, 20 mm that side and say 20 mm this side. Now for this I'll be giving relimitations. Limit 1 this, limit 2 this. This is how it will be created. You can see there is no such option available for clearance in this particular case. We don't have any option for clearance. This is your swept walls type number 1 flange. Another type, if I'll go ham, basically as per shape these types are created. Ham, everything is same. Relimitation type is there, basic type is there. If I'll select the edge, what will happen? In the flange case, I was able to define the angle. In this case, the angle is automatically or by default defined as 180 degree. This is your ham. So the major difference is of the shape only. The third case, if I'll talk about teardrop, selecting the edge, reverse the direction. This is your teardrop. What will happen? It will turn and got coincided with the wall itself. You can see if I'm increasing the length, it is maintaining the coincidence with the face of your wall. This is your type named as teardrop. And fourth type that we have is user flange. User flange is basically your type which is user defined profile case. I'll be selecting the edge and creating the profile. So creating the profile, say on perpendicular face. Say I want to follow this particular profile. Like this. I'll make the necessary constraints. Other constraints I'll keep as open. Say this coincidence. So I had made it coincide. Let's exit the sketcher. You can see it is not giving me any result. Why it is not giving me any result? Because this particular sketch is not appropriate. What we want over here is we want this particular sketch to maintain the tangency at this starting. If it is not maintaining, then we will not be able to get the result. Now over here I'll go for this and this to be tangent, as well as this point and this point to be coincided. Now check the result. Still it is not giving me the result. Okay, let's make some more changes. The more changes that I'm going to make is I am going to keep this complete curve as a tangent curve. Means there would be no involvement of sharp edges. See, so this is what the complete curve I have. Complete curve is tangent curve. See what it has done. It has given me the result. So user defined flange, what I need, okay, due to thickness it is not taking it. As a result, just reducing the thickness, say 0.5 mm, and yeah, now it is giving me the result. So this is the case. User flange, what I need to do is I need to create the complete flange or the profile of flange as tangent, then and only then it will give me the result, otherwise it will not. So these were the two major types of secondary walls we have: wall on edge and flanges. In the flanges we had four types. First one is flange, second one is hem, third one is teardrop, and fourth one is user defined or user profile. I hope the differences between these are clear to you, and you will be using these options, you will be using these things for your further work on sheet metal entities. Then we do have one more thing available, one more type of secondary wall, or one more option I will call it as, for creating the secondary wall, which is being used very rarely, but yes, it is being used. So for that I'll need to create a sketch first. I'll be creating a sketch over here, and the sketch will be something like this. I'll be maintaining some distance from this. So this is the case. You can make it fully constrained. I'll exit. So a curve I had created. What I'll do, I'll convert this particular curve into extrusion. Walls toolbar, extrusion to this. What will happen? This will give me an extrusion. Basically the extrude, but in the form of sheet or sheet metal. Okay, so this is your extrusion. What will happen? This extrusion will give you a wall, but no union has been done, because this particular primary wall and this extrusion has no relation as of now. But if I'll define the relation, then it will work. For defining that relation, I can go for this bending, select this, bend between this and this. Both the supports I had selected, cylindrical surface cannot be computed between two supports. As per the given value, the support cannot be created, so it will not give me the result. I need to make the necessary changes regarding either thickness or regarding the radius value. Then and only then I can get the desired result over here. So say if I'll make the changes from the 2 mm, the extrusion has already gone. I just remove this coincidence, keep it a little low, and say exit. No, it is still not giving me the result for extrusion. No preview can be possible. Okay, then keep it away, little bit away. Yeah, like this. And here I can try bend 1 and 2. Not possible due to fillet radius. I'll try with the internal faces 1 and 2. This is also not possible. It is unable to sense the cylindrical case. So in that case, I need to change this. Now bend 1, 2. Check the directions are okay. Preview. This is how the bend will work between extrusion and your primary wall. And now this is a single entity. Now you can play with fold and fold. This is your another type of secondary wall. So basically three types of secondary wall we have: wall on edge, flanges, and extrusion. But extrusion is very rarely used. So this is what we have for the day. Three types of walls we have seen: the primary wall and three types of secondary walls. So use this for your further work.